the last round. Not the least which, but it's very important.
Good morning. Can I please invite you to take your seats so we can start without further delay? Good morning. Good morning, colleagues. Good morning, friends. Thank you for coming. My name is Laetitia Demare, and I'm the Director of Climate Analytics Office here in New York. I'm also leading the work of our organization on implementation in developing countries. So we are very happy to welcome you today to this event, from the smallest islands to the highest peaks, ocean, ice, and climate change. Someone yesterday said at our previous event, you should come tomorrow to this event if you want to get depressed. And I really do hope that it's not going to be the result of this event and that what our experts will share with you are not so depressing findings. But you may have heard from this report that was released just yesterday by the IPCC, and we hope to provide you today with some of the key findings and the key messages from this report. Some of you may know of climate analytics, but for those who don't, I will give you maybe an overview of who we are and what we do. So we've been established in 2008 with our headquarters in Berlin. We have offices here in New York, in Perth, Australia, and in Lomé in Togo. We work with associates in different regions, including in Asia, particularly in Nepal, in Bhutan, in the Caribbean, and also in the Pacific. So our multidisciplinary team brings together experts and practitioners for very different backgrounds and experiences. Our activities have expanded over the years, so they include synthesizing and advancing science and knowledge in the areas of climate science in general, climate impacts, climate policy, implementation, and climate finance. We provide scientific and technical support to the most vulnerable countries, least developed countries, small island developing states, in international climate negotiation and over international fora. We undertake extensive analysis in the context of the 1.5 limit of the Paris Agreement, including linkages with the achievement of the Sustainable Development Goals. We also track and analyze the effectiveness of national climate policies, measures, and pledges against the Paris Agreement. And if you came to our event yesterday, that was the focus of the discussion. One of our flagship projects, the Climate Action Tracker, is dedicated to monitoring those progress. As I was mentioning earlier, the work that I'm leading for the organization includes supporting developing countries in implementing their nationally determined contributions, NDCs, and the national adaptation plans, and over climate strategies and policies into country-owned transformational actions and impactful projects at the national and regional level. But back to today's event, as I mentioned, our experts will share today with you the key findings from the IPCC report, special report that was just released yesterday. We will then open the discussion about the far-reaching implications of those findings for the most vulnerable countries. This event will be moderated by Mr. Christian Teleki. Thank you, Christian. Christian is the director of the Sustainable Ocean Initiative at the World Resources Institute, WRI, as well as the head of the Friends of Ocean Action for the World Economic Forum. Christian has over 2 decades of professional experience in the fields of environmental and ocean sustainability, and he has served as director of the International Coral Reef Action Network and as head of the One Ocean program at UNEP. So, ladies and gentlemen, again, thank you for coming. Enjoy the event and please engage in the discussion. Over to you, Christian.
Thank you very much, Laetitia, and delighted to be here. This is obviously a critical subject for us all. Yesterday, the IPCC report for the cryosphere, oceans, and climate change was released and confirmed what we all have been thinking. The ocean is getting hotter, higher, and more acidic. We also know that the cryosphere is shrinking. But the question is, what does this mean for our livelihoods, our people, the biodiversity around the world, especially those that are on the front lines of climate change in least developed countries and large ocean states rather than small undeveloping states? Because these are small island masses that are surrounded by vast areas of ocean and are deeply affected by the changing climate and changing ocean. So during this session, we are going to explore whether this report is enough of an alarm bell for us to accelerate the transition to a low-carbon economy. What does it mean in reality for those peoples whose lives are intertwined with the ocean and the cryosphere? So we hope to have an engaging session. You'll hopefully learn a little bit more about what does the IPCC report mean. And I would also say that whilst it's easy to be depressed about the report that came out yesterday, equally is an opportunity to challenge us and rise to the challenge that we see there. And I used to work for a while ago. I used to work for the Prince of Wales, and I remember him having a conversation with his son, Prince Harry. And the Prince of Wales said to his son, I am so sorry about the world that we are leaving to you. We have left it a complete mess. And Harry said, actually, yes, but this is our challenge. This is our opportunity to fix it. And so I think that's the whole sentiment that we're seeing of sort of this rising, sort of sense of frustration of the action, the hope that we need to turn that around, actually do something about it. And I think this is our opportunity. And no place to start with certainly is in least developed countries and large ocean states. So what we'll do this morning is we'll have two presentations that dig a little bit deeper into the IPCC report. What does it mean? So you get a little bit of understanding it. I'd ask you to sort of jot down your questions, and then what we'll do after those two presentations, we'll pause a little bit, and you'll be able to throw some questions at our distinguished experts here. And then we'll have a bit of a switch, and then we'll start to getting into some more of the political policy dimensions of this, again, with some distinguished panelists to talk a little bit about, from their perspective, what does it mean? So again, we want to keep this engaging and light so that you come away with this feeling like you have a good sense of what the report means and what does it then mean for those that it's going to impact. So it's with great pleasure that I get to firstly introduce Adele Thomas, who's the Senior Caribbean Research Associate for Climate Analytics. And Adele, before you come up, I want to acknowledge that Adele is from the Bahamas. And Adele's country was devastated by Hurricane Dorian. And so I think, there's no better person, I think, to really talk about what does this report mean in reality, not an abstraction, So even though she's giving this telling you about this report, I urge you all to reflect about what does it mean for her, and her country in the Bahamas being on the front line. So with that, Adele.
Well, that was quite the introduction. Thank you. So good morning, everyone. I'm pleased to be here with you this morning to present to you key messages from the special report on oceans and the cryosphere, or ASROC, that are particularly relevant for LDCs and SIDS. So this special report is the latest in the IPCC's current and very busy 6th assessment cycle. It was preceded by the special report on 1.5 degrees that came out last October, and by the special report on land that was just released last month. And after this last special report on oceans and the cryosphere, the comprehensive 6th assessment reports will be published in 2021. So it's a very busy time for the IPCC. So this special report, ASROC, has a mandate to focus on 3 particular areas. First, to assess the physical science basis and impacts of climate change on high mountain areas, polar regions, low-lying islands and coasts, oceans and marine ecosystems, as well as the human communities that depend on them. Secondly, to assess the vulnerabilities and adaptation capacities for both human and physical systems. And thirdly, to look at options for achieving climate-resilient development pathways for these particular areas. Now, notably, mitigation options were not included in the scope of the report, and so there's not much information in there on mitigation in particular. So, although changes to the ocean and cryosphere have direct and indirect impacts on all of Earth, LDCs and SIDS are particularly affected by changes to the ocean and the cryosphere. And I'll just briefly provide two examples to show why this special report is so critical for these countries. So take, for example, Nepal, a high mountain LDC that is already experiencing both drought and excessive monsoon flooding due to climate change. High-intensity rainfall and glacial lake outburst floods have resulted in landslides, soil erosion, and extensive flooding events. Incessant monsoon rainfall in July of this year has had widespread impacts, and this catastrophe follows a much larger flooding event back in 2017, where over 450,000 people were displaced. In my home country of the Bahamas, I think we are all aware of the ongoing crisis caused by Hurricane Dorian, which is the most powerful tropical cyclone to affect our nation. And again, this follows severe impacts that we experienced back in 2017 when Hurricane Irma made one of our southern islands being deemed uninhabitable and caused all of the community members to have to be vacated and left the island completely uninhabited. So SIDS and LDCs are already experiencing climate impacts that are associated with changes to the ocean and cryosphere. And this special report is an important piece of work that lets us know what we can expect in the future. So this morning, I'll be sharing 5 key messages from the Summary for Policymakers, which was just approved and released yesterday. So this is hot off of the presses. And I'd just like to state up front that this is a condensed presentation of the SPM. The SPM itself is almost 50 pages long, and the underlying report is over 1,000 pages. So there's lots of information in there, but I'll just be presenting some of the key messages that are relevant for SIDS and LDCs. The first key message is that we are already experiencing widespread shrinking of the cryosphere in locations around the world, as well as decreased stability of high mountain slopes. While Arctic sea ice has decreased for all months of the year since 1979, sea ice changes in September are unprecedented for at least 1,000 years, which is incredibly alarming. These changes to the cryosphere have significant implications for ecosystems and communities. For example, Nepal, Bhutan, and Afghanistan are landlocked LDCs with strong dependence on the meltwaters that come from snow and glaciers. Changes in the amount and the seasonality of meltwater have profound impacts on people, their livelihoods, and the overall economies of these countries. Glacier retreat and snow cover changes have contributed to changes in the amount and quality of water resources, and this has led to agricultural yields being declined in some high mountain regions. There are also changes linked to disasters such as landslides, avalanches, and floods, and we are already seeing that tourism, hiking, and mountaineering have been negatively impacted in many mountain regions. Also, we've seen plants and animals have changed their location in response to the reduction or complete loss of snow cover. Unfortunately, it is projected that these trends will continue. Depending on the level of emissions, we may see a reduction of up to 36% of glacier mass by 2100. Smaller glaciers are particularly at risk, with many of them being projected to disappear completely. Disasters associated with these changes to the cryosphere will occur in new locations or during different seasons, which present significant challenges for adaptation and will likely result in increased damages. And these changes also reduce livelihood options as agriculture and tourism become less feasible. The second key message is that oceans are already warming rapidly. we have seen a doubling in the rate of ocean warming since 1993 as the oceans absorb the majority of the heat that has been added to the climate system. This has led to marine heat waves becoming more frequent, lasting for longer periods of time, becoming more intense and also more extensive. We have seen a doubling in the frequency of marine heat waves since 1982. In addition to becoming warmer, oceans are also becoming more acidic as they absorb carbon dioxide from the atmosphere. And this makes it harder for some marine species to build their shells and skeletons. These changes to the ocean have resulted in a shift of marine species towards the poles. So we are seeing fisheries move away from the tropics. And this has already resulted in challenges to fisheries governance in terms of regulating fishing between national jurisdictions. Nearly half of all coastal wetlands have been lost over the last 100 years. And this is due in part to climate change, but it's also a result of localized human activity. These coastal ecosystems, such as mangrove forests, not only store carbon, but they provide essential ecosystem services such as coastal protection. So loss of these ecosystems has widespread effects for coastal communities. Marine heat waves have already resulted in large-scale coral bleaching events that are happening more often and have caused worldwide reef degradation since 1997. Recovery of coral from these bleaching events is slow, taking more than 15 years, and that's if recovery happens at all. And we are also seeing changes to algal blooms, such as the sargassum seaweed that has been pervasive throughout the Caribbean. And these blooms have negative impacts on food security, on tourism, on local economies, and on human health. What we are seeing now is only a taste of what is to come. We can expect to see unprecedented changes to the ocean as temperatures rise. These changes will result in further decline in fisheries catch potential, which will affect tropical regions in particular. Marine heat waves are projected to further intensify. Their frequency will be 20 times higher at 2 degrees of warming and will occur 50 times more often under higher emission scenarios. Warm water corals are particularly vulnerable to these changes in the ocean and are expected to suffer extensively even at 1.5 degrees of warming. As temperatures increase, virtually all of these corals will be lost. Changes to the ocean also affect the safety of seafood for human consumption. So marine plants and animals are projected to have higher levels of pollutants and mercury, along with increased levels of waterborne pathogens. And these risks will be particularly large for communities that consume high amounts of seafood, such as coastal indigenous communities. And this will have negative impacts on traditional diets and food security. The third key message coming from the special report is that sea level rise is accelerating. During the 20th century, the global mean sea level rose by about 15 centimeters. The current rate of sea level rise is unprecedented over the last century and is increasing. We may see a sea level rise of up to 1.1 meters by 2100 if emissions are not sharply reduced. We are already seeing changes in Antarctica, which has the potential to lead to irreversible ice sheet instability and result in multi-meter sea level rise in the centuries to come. And these changes in sea levels have already resulted in extreme coastal erosion and flooding that has had severe impacts in SIDS and coastal LDCs. As temperatures rise, we can expect sea levels to continue to rise at increasing rates. Extreme sea level events are also projected to happen more frequently. Extreme sea level events, which have been historically rare, occurring once every 100 years, may occur annually by as early as 2050. The report very importantly notes that sea levels will continue to rise even after emissions have been stopped. And depending on the level of warming, we may see multi-meter sea level rise by 2200. Changes in sea levels and their associated impacts may also lead to some island nations becoming uninhabitable and requiring the relocation of entire communities. The fourth key message is that we are seeing an increased intensity in tropical cyclones due to climate change. Sea level rise and increased temperatures of both the ocean and the atmosphere have led to these storms having more intense rainfall, higher winds, and more extreme waves. The intensity of tropical cyclones is projected to increase as temperatures rise. We may also see a higher proportion of the most powerful storms, so that's the category 4 and the 5s with the fastest wind speeds. Storm surges are also expected to increase due to sea level rise, and we know that storm surges are often the most dangerous and destructive parts of tropical cyclones. And the final message is that adaptation is essential, but adaptation cannot address all of the increasing risks from climate change. A variety of adaptation options are presented in the report. This includes protection, for example, dikes, accommodation, such as early warning systems, coastal advance, and managed relocation. However, adaptation is already presenting a challenge to governance arrangements. The time scale of climate impacts is often longer than planning cycles, public and corporate decision-making timeframes, and available financial instruments. And so these differences in time frames challenge the ability of societies to adequately prepare for long-term changes. Governance arrangements for adaptation are also often fragmented across administrative boundaries and sectors. There has been lots of discussion lately on ecosystem-based adaptation, and the report finds that these approaches may be effective for limited levels of warming, but as global temperatures rise, there are limits to relying on nature. For example, coral reef restoration is likely to be ineffective if temperatures exceed 1.5 degrees. Adaptation also takes place in the real world, and there are financial, technological, and institutional barriers that affect implementation. And these barriers result in adaptation not being as effective as planned, or they may even lead to limits to adaptation. And finally, despite our best efforts at adaptation, there will be residual risks and associated losses. As temperatures increase, there are limits to the various adaptation options that are available, and our options to adapt become constrained as temperatures rise. Even transformational adaptation measures, such as planned relocation, come with a suite of drawbacks. And this includes loss of social cohesion, cultural identity, and in some cases, loss of sovereignty. So despite major adaptation efforts, there will be risks that cannot be eliminated. So these 5 key messages highlight the overall message of the report, that choices made now are critical for the future of our oceans and cryosphere, as well as the ecosystems and people that depend on them. The SROC shows that risks of climate change increase as temperatures rise, that SIDS and LDCs are already experiencing significant impacts, and that changes to the ocean and cryosphere have widespread effects. The report underscores the need for great urgency to address climate change in a coordinated, comprehensive, and transformative manner. And with that, I turn it back to Christian. Thank you.
Thank you very much for that, Adele, and some really important insights, I think, on the report and what it actually means in real terms. Before I introduce the next guest, I just want to remind everybody that this is being live streamed. So when we do get to the Q&A, you might decide whether or not you want to ask your question, knowing that it's being live streamed. I just want to mention that so we're all understanding that. So let's go further into this. I mean, what does it now mean in terms of mitigation potential, and get further into more of some of the science of the report? And I can think of no better person than Mikhail Schaefer, who's the science director for climate analytics. Mikhail, would you like to come up at the podium, please?
Thank you very much. 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 Thank you very much Thank you very much, Christian, and thank you for all for coming. And thank you, Adele, for the very sobering overview of the report. So next, we would like to take you through a few insights of, okay, what can we now do about it, right? Obviously, international climate finance, adaptation, dealing with loss and damage, those are essential. But it will all be made incredibly more difficult if we don't deal with mitigation and get to a very deep global emission reduction pathway. So I will, in the next 15 minutes, will take you through some of the implications that we draw from the report for mitigation, and in particular, also going through the things that we can actually do. In the connection with the Paris Agreement, of course, we all know that the big one of the major advances is to have the 1.5-degree limit in the Paris Agreement. The special report doesn't speak a lot on 1.5 degrees. There is a bit of information in there. So what I'll do is then I'll pick out those elements and then make some further connections with the underlying literature, and then connect it to what does it mean for the actual system, energy system transformations and other emission reduction that we need, and how does it connect to NDCs? All in 15 minutes. This is actually a very good place to start in terms of starting to speak about mitigation. This is the first figure in the SPM of the special report. It's not even complete. This is half of it. The other half is on the next slide. But it's a very, very condensed, huge amount of data, information, computer results, and underlying literature. And here, for all of the indicators we have here, the authors compared a high emission scenario, which leads to 4 degrees warming above pre-industrial by the end of the century, and a low emission scenario, which is not quite 1.5 degrees. It reaches 1.6 degrees mid-century and then stays there until the end of the century. If you go to a few of the indicators, for example, here, let me take that. Here we have marine heat waves. So these are the events that cause coral bleaching, for example. And we see a very large difference between the high and the low, which I'll come back to later. On the top right-hand side, this is an indicator of ocean acidification, so the pH of the upper ocean layer. And if you compare the declining levels of pH means increased acidity. And if you reach levels around here, then not only do you block coral reefs from growing, but it actually starts to actively dissolve the coral reefs. I'll come back. There's permafrost indication, which is both related to high latitude as well as high altitude structures, and I'll come back to that later. Sea ice, where there is a strong decrease in Arctic sea ice for all scenarios, but then a substantial difference later on in the century between high and low scenarios. Now let's move on to the second half of this figure, which is on sea level rise, and we have here different components that all contribute to global sea level rise. This is simply the expansion of ocean waters as the ocean take up a lot of the heat, additional energy kept in the system. Greenland ice sheet, Antarctic ice sheet, other glaciers across the world. And one essential difference with progress compared to the last IPCC report, the fifth assessment report only a few years ago, is in research on Antarctic ice dynamics and observations, which leads this author team to have a higher risk related to accelerated thawing of or melting of the Antarctic ice sheet. And that translates into sea level rise over the very long term. This doesn't stop at 2100, but it continues until 2300. Getting all of those processes in play with these high and low scenarios, with a very low near 1.5 degree scenario, we end up with still a meter of sea level rise over centuries, but it's very slow. And of course, that's good news for adaptation. However, with an unconstrained emission pathway, not only do we see, let's say, a best guess or medium, which rises very, very rapidly and continues to rise very, very rapidly for centuries, but we also see this risk assessment being very, very broad. And this doesn't even go up to levels like a 90% level or something. This is the likely range, so that means that 2 out of 3 sort of simulations or projections fall within this region, and a 6th of them falls above this, which is very, very substantial. So from a risk perspective, it's really quite dramatic. Good, but we see this huge difference with the low emission scenario, not just in its best estimate, but also in the risk assessment around that best estimate. Now, a word about permafrost. Please don't read all of this. This is literally a copy from the summary for policymakers. The key message here is that a thawing of permafrost, again, both high latitude and high altitude, releases carbon in the form of both CO2 and methane. And this is very, very substantial. Hundreds of billions of tons, tens to hundreds of billions of tons. And if you compare that, which I do in the report itself, with an estimate of current anthropogenic emissions, you see that this is several years to decades worth of current emissions. And that is, of course, for the high emission scenario, and the risk is much lower again for the low emission scenario. What has been for many years a very important way to summarize the risks in IPCC reports are the so-called reasons for concern, where they have sort of categories of impact categories put against the vertical axis of risk, from no risk, low, medium, and high risk. And this is from the special report on 1.5 degrees, which focused on the area of risk, let's say, between 1.5 and 2 degrees and around it. Obviously, the special report on 1.5 specifically considered 1.5 degrees. The SROC does less so, but what it does do, it extends these same reasons for concern upward to the 3 to 4 degree range. See what it does there, which relates more directly to the current pathing that we're on. However, the special report does cover more than just ecosystems. In the SPM of the SROC, it's only focused on ecosystems. So it doesn't include, for example, fisheries, Arctic region, or coastal flooding. Whereas the special report on 1.5 degrees shows that exactly these categories, they already have high risks or medium risks around 1.5 degrees, which rapidly increase in the 1.5 to 2 degree region. And so that's very, very important information, and therefore we think that these two reports really in conjunction provide a full overview of interest for the Paris Agreement implementation. Okay, now a few more things about 1.5 from the literature. This is on marine heat waves, as I explained earlier. This is what's causing ocean bleaching. We have a very much higher probability of ocean heat waves under 1.5 degree compared to today, so that's a very considerable risk, so continued color bleaching. But this increases rapidly still for 2 degrees and 3 degrees. So there's a really very big difference again between 1.5 degrees and higher levels. Adele also spoke a lot about coral reefs. The chance of survival or the threat to global coral reefs is very considerable under 1.5 degrees. And we already know that coral reefs are suffering today. But under 2 degrees, there's virtually no chance of survival. Then I believe this is the final category of impact. This is on Arctic sea ice, and it is the probability that the Arctic is ice-free in summer, and in particular in this case in September. And in so this is the result, sort of a probability statement of an ice-free summer under 1.5 degrees here, which compares to roughly once every 40 years. Under 2 degrees, which translates into roughly every 5 years, so there's a very big difference. And then at 3 degrees, again, the pathway that we're roughly on at the moment, this would be practically every year. So by that time, by the time we reach this level of warming, every year will be ice-free, with huge implications for ecosystems. Sea level rise, right. Again, like I said, the report looked at the very long term, and there's a lot of literature now looking at that. And 1.5 degree really means, on a time scale of multiple centuries, 1 to 1.5 degrees, but there's really multi-meter, 6.5 sea level rise if you go to higher levels. Again, this extreme difference between action now versus to continue to high emissions. This is a recent paper that we just, our colleagues just got accepted, which is great. And this is a very, very concrete, very direct connection they made between cumulative emissions and sea level rise, and what is implied by the current NDCs. The current NDCs, even the emissions from now to 2030, so let alone emissions following, already commit to a meter of sea level rise to the year 2300. And if you then look, so that's globally, but then if you then look at, as our colleagues did, at the top 5 emitters, their emissions between 2016, adoption of the Paris Agreement, to the 2030 end of the current NDC period, even those 5 emitters alone contribute 10 centimeters of sea level rise in the long term, just by the emissions in those years. Let's turn to the policy area, to the mitigation policy, I should say. Here, this is work from our Climate Action Tracker project, together with New Climate Institute, which has been going on since 2009, and at our event yesterday, this was reported on quite extensively. I just want to summarize here the main takeaways, which is that there's a substantial difference in emission pathways that are consistent with the current policies and NDCs, between those and a 2 degree or a 1.5 degree pathway. So you see there's a very big difference, not just in the 2030 levels, which relate to NDCs and current policies, but the implication it has for the rest of the century in terms of the inertia in the energy system and the difficulty to turn it around once you continue building, for example, coal-fired power plants. So where do we get? In current policies, we get to about 3.2 degrees by the end of the century. For the NDCs, we get around to 2.9 degrees. So far above the long-term temperature goal of the Paris Agreement and the 1.5 degree limit. What can we do, though, to keep the warming limited to 1.5 degree? First of all, total net greenhouse gases, they need to peak about in the next few years. They need to reduce very, very substantially and rapidly to about 45% below 2010 levels by 2030. And so NDCs need to be brought in line with this kind of reductions globally. Then they need to turn zero by 2070. And then followed by negative emissions, so a net removal of CO2 after that. So if you look at that, let's say more from a little bit unpacking what you see here, this is again this global total greenhouse gas emission curve with its benchmarks, peaking, decline, zero and negative. We see emissions from the energy system which have to decline very, very rapidly, but then if not reduced to zero completely, have to be compensated in the yellow by negative emissions in that same set of sectors, and then assisted by net uptake in managed ecosystems. And then the non-CO2 gases, which is in the light gray here, there's a substantial part remaining related to our food system. So also there a lot can happen, but in general, literature is not sees a lot of residual emissions still remaining, which then also need to be compensated again by this net uptake in other sectors. It means a fundamental transformation in all sectors. This is an overview that we did a while ago of what is in the special report on 1.5 degrees. Really, what is the transformation we're speaking of? We speak of electrification of about everything, all of the sectors. That can only be effective if at the same time we get zero emissions from the electricity system itself. The electricity system has to decarbonize completely before 2050 to make this possible. And a lot of implication it has for how does it actually need to happen then. It means battery systems, it means green hydrogen including in the industry system. It means a very rapid upscaling of renewables to 75% of the electricity system and above. It means reducing emissions in agriculture. And of course, it means transforming the forestry sector from a net source to a net sink, taking up carbon instead of emitting. One element which is, I think, the most robust of any results of the special report of 1.5 degrees is the phase out of coal. And it doesn't really matter if you look at so-called 2-degree scenarios in the yellow here, or if you look at 1.5 degrees yellow. It makes a difference of, let's say, 5 years in terms of how fast they need to be reduced. But it has to go, and it has to be completely phased out globally by 2040, and the earliest in OECD countries by 2030 around. Well, how does this need to happen? As I explained, it means it means electrification of sectors, but it also means an incredible leap in energy efficiency globally. It means that we have to look carefully at bioenergy and CCS and keep this within sustainability levels, but it needs to be scaled up from the 2030s onwards. And how are we doing then if we look at individual countries in this regard? This is again turning back to the Climate Action Tracker project, but not then at the global level, but breaking it down to the 30-odd countries that we've analyzed in very much detail. This is a rating that we do every year, sometimes even every half year as events warrant. As you can see, by far the most countries, their NDCs are insufficient to get the world on a 1.5 degree pathways. There are a few examples, and obviously those need to be growing in number very rapidly. Some countries, they do make a lot of progress in all of these categories, but also countries that are doing very, very badly, not just in the NDC as it currently related, but also in terms of any movement we see in their policies. If we talk then about ramping up NDCs, this is a study that we just finished as well. We start out with that Climate Action Tracker global scenario of emissions under current NDCs. And we just asked a very simple question, like what happens with these emissions and the warming related to it if we increase the ambition of NDCs all around. So this is an indicator of how NDCs are being ramped up globally and what it does to temperature increase by the end of the century on the far hand right. So if we do this for all countries, not just for the countries that we include in the Climate Action Tracker in depth, but we do it for all countries, then we really need to look at 40% below NDC levels globally to get to 1.5 degree range. All the rest, small changes, small improvements, small incremental steps, they really, really don't get us even near the global goal. And then finally, to link this back, the same to the impacts that we started with. In the same paper, we're looking at, so what do they imply for some of the impact categories? Just pointing out sea level rise, since we're talking about the ocean and cryosphere report here, we do see a substantial effect of a 1.5 degree scenario compared to the NDC reference scenario, a reduction from about 64.5 centimeters by the end of the century to 45, and then again in the long term, this commitment of almost 2 meters in the NDC scenario is halved in the 1.5 degree scenario, so a very substantial difference. Good, well then, as an overview, it is a very sobering report, there's no denying it, as was Adele's overview of it. There is, however, very, very much that we can do to avoid the worst consequences. Looking at, for guidance, at these two reports in conjunction is essential, not just to see what is heading our way, but also how we can prevent the worst. It's clear that NDCs and current policies are not sufficient to get us to 1.5 degrees, but it is also very clear that it is still feasible. However, if we look at it and we look at just the next 10 years in terms of emissions committed under NDCs and what they imply for future impacts, we really have a critical window of opportunity that we have to grab now and to substantially update and enhance NDCs for virtually every country. Thank you very much.
Thank you very much. Thank you very much. Thank you to you both for those very insightful presentations. Obviously some sobering facts and figures from the special report. Now what I'd like to do is sort of open up for some Q&A. You might have some questions of clarification, some insights that our panelists can offer. But I do encourage you to use this opportunity to perhaps seek a little bit of clarification. So I open the floor for anyone who'd like to start the questioning off. Yes, sir, in the background there. Could we please get him a microphone? Ella? Your microphone right there? Thank you very much. Sir, could you tell us who you are and the organization you're from, please? Thank you. No. There you go.
Thank you to both the presenters for your brilliant and enriching presentation. My name is Sid, and I'm the advisor to the ambassador of Vanuatu to the United Nations, Small Island Developing State of the Pacific. In short, my question is about the ocean actions and the wider climate change agenda. I recently attended the Climate Action Summit, and I just wanted to ask the presenters your views about to what extent do you think the 9 coalitions, the tracks that have been set in the Climate Summit, to what extent they're going to be effective in dealing with the ocean problems? As we already know from the presentations that climate change and acidification are having like a range of serious threats which are further compounded by anthropogenic activity like seabed mining, pollution, destruction of marine ecosystems, overfishing, and so on. Thank you.
Very good. Adele, do you want to come in on that first? Yeah, I think it is. Just go ahead.
Hello? No? It was? Oh. Okay. Okay, I haven't gone through all of the statements that were made, but I do know that we need transformational change in order to limit temperatures to 1.5. So the special report on oceans and the cryosphere is very explicit in saying that the differences between low emissions and high emission scenarios have extensive impacts that are particularly relevant for SIDS, which you indicated with your fisheries. So unless we have not only transformational commitments, but actual action to implement those commitments, then we're going to see some of the devastating impacts across SIDS and LDCs. Thanks.
Mikhail, do you want to come in on that? Yeah, son.
Okay. Yes, thank you, Adele. I just want to add that there's also a lot of actions that reinforce each other, right? So it is as we said, mitigation is essential. It really needs to be transformative, but there's a lot that can, let's say, build resilience or strengthen resilience of both human and natural systems. For example, if you look at the SDGs, if they would all be realized, then it helps actually in increasing resilience. I think that's very important, and vice versa. A lot of the mitigation and adaptation actions, they have benefits for SDGs and realizing SDGs. So I think these interlinkages, they would be very helpful also as guidance for efforts around the world to protect oceans and coastal systems.
I think this is a very important point in terms of connecting into oceans. And if I may, with the moderator's privileges, do a shameless plug. I also, one of my portfolio, I lead the Secretariat for the High-Level Panel for Sustainable Ocean Economy. And on Monday, with 14 heads of state, we launched a report, The Ocean as a Solution for Climate Change, looking at 5 opportunities for action. And in this report, we looked at 5 different sectors: ocean-based energy, renewable energy, ocean-based transport, coastal marine ecosystems, fisheries, aquaculture, and dietary shifts in carbon storage in the seabed. And if we looked at these in terms of, if you implemented these solutions, that would deliver up to 1/5 of the annual greenhouse emission cuts the world needs by 2050 to keep the temperature below 1.5. So that's about 21%. And that's equivalent to taking, to all the emissions of all the coal-fired plants globally, or taking 2.5 billion cars off the road. So I think there are certainly some solutions out there that we can undertake. But I have some spare copies of these if anyone wants to come see me afterwards. So with that, please, you had a question.
Thank you very much for the presentations. It's terrifying.
Could you just use the microphone, and could you also introduce yourself, please?
I am from Belize, as you know, Adele. And I think from a planning perspective, it would be interesting to know whether or not small island developing states and least developed countries should actually be looking at worst case scenarios. And I'd like your views on that. And I take the point, Christian, that there are certainly low-hanging fruits to be utilized or deployed to deal with potential mitigative capacities, for instance, from integrated coastal zone management and things of that nature. But Adele also pointed out that that goes to a certain limit of temperature. So I would appreciate your insight. Thank you.
Adele?
Yeah,
Thank you.
sure. So I think that we do need to look at worst case scenarios. I mean, we have been fighting for the need for action to limit temperatures to 1.5, and we have a very short time frame to meet that. And so I think we will know very soon if we do need to prepare for a worst case scenario. But I think what's also important to take into account is we are already experiencing worst case scenarios in our current experience. So for example, Hurricane Dorian and the storms in 2017, all of them broke records as extremely powerful storms. So we are already facing worst case scenarios even just at 1 degree of warming. So definitely I think we need to prepare for the worst as we are already experiencing significant impacts.
Thank you. I believe Michael Oppenheimer, do you want to come in on it? Michael is the, just so you give some context to introduce you, is the professor of geosciences and international affairs at Princeton University. He's also the director of a Center for Policy Research on Energy and Environment at Princeton's Woodrow Wilson School. Welcome.
Thank you. I also am an author on SROC, and I wanted to, first I apologize for being a little late. Not only am I jammed up with media yesterday and today, but the New York City subway system is in partial collapse, so that tied me up. Just on this point, could I show, I didn't think I was going to have time to put together any slides, but I did. Could I show one in this context in particular?
So while we're waiting for that, perhaps if we could take another question from...
Yeah, go ahead.
Yeah, if you just bear with me. Yeah, please. Yeah, please, yeah.
Hi, my name is Indra Heerkens and I'm from the IKEA Foundation. As the report is published yesterday, the world must know how bad it is, the situation. I was just wondering how you're going to communicate the critical windows of opportunities to all those countries.
Mikhail?
Well, there's a narrative that's always evolving in terms of the importance of 1.5 degrees as a limit in the Paris Agreement and the ways to achieve it. That narrative is built of the need to get to 1.5 degrees, why it is so important, the ways to do it, and then the benefits and co-benefits of achieving this. So across that narrative, we have found it to be very effective in many countries to be across it, the full spectrum. So not just pinpoint the risks and the problems. And as science progresses, actually, many of these impact categories get worse as time moves on. Not just as what we observe today, but even at the projection level. But always then offered solutions. Solutions, again, across the spectrum, focusing very much on mitigation, because without the mitigation, everything else is very, very hard, even harder than it is with strong mitigation. And then, also offer an overview of the cost and benefits and co-benefits across all the policy areas, not limited to the climate policy area alone.
I think just to building on that, I think part of it is really the economic case for this, right? I think it's really trying to understand the economics. What are the trade-offs and opportunity costs? And I think we're increasingly seeing that what we saw, what's been presented in the report here, has significant costs. And I think the investment, is needed in order to offset that. So I think that's an important element to communication, because that's going to, whilst this is important, I think people have to understand how is it going to hit them in the pocket and the bottom lines, especially on so the corporate level as well. I think it's quite important. Perhaps we'll take two more questions in this session, and then we'll sort of switch over panel. So, sir, yeah, please, there. Oh, sorry, beg your pardon.
Yeah, no problem. So, two quick questions. The first was, given that, the IPCC admits that they have not yet incorporated permafrost into their calculations, nor the lower probability, but still non-zero probability of methylclathrate emissions. What level of confidence do you have that we're not at a much worse scenario than we're? Because there's more. Those are the two largest stores of carbon on Earth, and they're not at all accounted for in the IPCC results. So I would think that we would really, really want to be looking at those kinds of things. So I would love to hear. I'm sure you guys are aware of that. I would love to hear what your thoughts were on that. And the second question was in terms of modeling. I was wondering what your thoughts are on trying to develop sort of near real time, or at least semi-annually updated, look at all the things that people are doing that are in sort of a similar data format, so that we can start doing a real-time modeling of how things are actually progressing, and then also taking a look at modeling for some of the possible geoengineering scenarios.
So almost like a dashboard, right? So you
yes.
can see it. Okay, so I tell you what, Adele, why don't you take the first question, and then Mikhail, we'd like to come in on the second one? Great. Please.
Sure. So just briefly on the first question, the SPM and the special report on oceans does have some information on permafrost. I think what's important to highlight is the IPCC reviews existing literature, so they can only report on what literature is out there. And so speaking to your point, if there isn't literature that speaks to this increased carbon storage that's in permafrost and that there may be much more emissions, this just further adds to the need for us to limit temperatures, because we may, be experiencing worse impacts than or on the verge of experiencing worse impacts than we currently know. But we know already that we need to limit temperatures, so that, you can have more and more and more science. And I personally, I'm like, how much science do we need before we say we need to limit temperatures? Like, to me, it's pretty clear, you know, so we can have more science, yes, but I think it's already very clear that we need to act now.
I think sadly it's the case. It's just, we're constantly loading up science, and I really don't think that, we see it across the spectrum really in a whole range of issues where the science is mounting, but.
Well, I mean, my question was more about because we're also basing timelines on a certain scenario and a confidence in numbers without full confidence in what are the absolute largest sources of carbon. Now that doesn't seem to me to be here we have 15 years, but we haven't included the two possible biggest emission sources. That doesn't seem like, hey, I'm looking for more science. It's, hey, maybe we're being as dire as we're being. We may in fact be looking at it through rose-colored glasses.
So and just if I can just sort of contextualize that, I think what you're saying is, the question is, Adele, is the release of CO2 and methane in the permafrost, is that really actually accelerating it? Are we in like a self-reinforcing system that actually is it a vicious circle? And is there enough evidence to suggest at the moment that, we've come up with a potential trajectory, but actually is it accelerating at a much faster rate than we're originally documenting at the moment?
Yeah, I think I can respond directly to what extent it is and is not included in models. There is, of course, science looking at this in a model context, and there's a very large difference between low emission scenarios and high emission scenarios, and that's also coming out of the special report. That nice brief statement that I showed from the SBM on permafrost. As you get to high emission scenarios, yes, you will have a very, very substantial additional emission from permafrost regions, which most of it can be avoided on a low emission trajectory. So that's the first, sort of evidence that we need to work with. And if you include that in actual mitigation scenarios, and there has been some work on it, what you see at a low level of emissions, let's say around 2 degrees, is that it causes a almost permanent additional source of emissions in the Earth system, apart from all of the anthropogenic emissions. And if you then, around 2 degrees, you reduce anthropogenic emissions completely to zero, or even slightly negative, you will not be able to drop the temperature below 2 degrees for centuries because of that continuous, slow, but substantial additional emission element. Maybe then briefly on the question of real-time modeling. We are actually working on it in many different ways. But there's a few key issues that we're trying to understand how to deal with, which is that if you look at non-state actors, you look at actions in cities, companies, you name it. You need to be very careful how you account for this ultimately at the global level. What is additional, what is not? And so there's apart from all of the scattered data, the data formats that you mentioned, there's a lot of work to be done still to be able to get to that level of real-time modeling.
So the message is we're working on it. That's a good idea. So I think it's a very good idea. I think what we're going to do is I want, Mike, if you could just briefly respond to the question here, because we want to switch over to
I'm just going to go to this question.
Great. So while he's doing that, can I ask you to go down, and Mr. Wangi and Ambassador, can I ask you please to come to the floor? Thank you.
So this gets to the point about worst cases. There's been a lot of struggle in the scientific community and the IPCC community about how to talk or whether to talk about worst cases, because frankly, from my point of view, from a lot of people's point of view, we don't have any idea what the real worst cases are. There are too many of the unknown unknowns. So it's deceptive, really, to talk about worst cases. And in the past, when we talk about worst cases, with regard to a lot of aspects of the problem, we blow through the worst case anyway. So what's the point? So instead, the community has moved towards trying to develop probabilities and then admit what they don't know. IPCC has gradually evolved in that direction as well, although IPCC lags some of the thinking in the community. It's finally catching up. Let me give you an example on how you have to be careful about how you read the report. with regard to sea level rise. IPCC's projections for sea level rise and extreme events are within the constraint of being derived from what are called process-based models, the models that contain the full physics as we know it, and biology, et cetera, of the climate system. Everybody knows that on many key points, these models have a lot to learn. But still, when they say that something is going to be, it's likely that some occurrence will happen, like in this case, it's likely that sea level rise in 2100 will be between this limit for the RCP 8.5 or this range for the RCP 2.6. That should always be understood as within the range that the current process-based models tell us. And the question has always loomed, what about outside the range? And all that is, this spans the range of the 17 to 83% possible outcomes. But policymakers don't give a damn about 83%. They want to know something that looks in many cases like a worst case. But if you can't say that, what about the 90th percent? What about the 98th percent? What about the 99th percent? In other words, what's the 1% top worst events that can happen? That's something that the science, at least on sea level rise, is starting to be able to do, but IPCC has been slow to include these. So this time, IPCC did something different. It used three methods that were not process model based entirely to derive other estimates than the process-based models, but at the same time also can offer the 5 to 95% range. In other words, what's the 5% worst outcomes that you can expect? And they're on some of the figures. Most people didn't notice them. One of them is in the chapter and not in the SPM, but here's from the summary for policymakers. This is from what's called an expert elicitation, which is a very structured way to get information from experts that transcends, but it also incorporates the process-based models. And for the sea level rise in 2300, it's very close to what the process-based models say. Kind of encouraging, I guess. Either that or everybody's drinking the same Kool-Aid, and you can't be sure. But look at the lower range, RCP 2.5. The range from the expert elicitation is quite large and goes up to around 2 meters. Now, you can see that in the SPM, but if you dig in the chapters, let's see. No, that didn't work. Somebody's going to have to save me. Yeah, I screwed up. I always screw up with these things. Yeah, why don't you get it back and then stay there and change it? Okay, I want to be on whatever the next slide. If you look in the chapter at figure 4.2, you'll see, now go to the next slide, you'll see a slightly different story where there was room to print all the results, or perhaps it was courage, I don't know. And you see, this is the chart, this is the this inset reflects the time to 2100, and IPCC actually listed three different ways, three more or less independent ways of doing this beside looking at the process-based models. And there you notice the differences are even larger, so that the expert elicitation for 2100 goes up to 1.35 meters of sea level rise. And that's just the likely range. You could look in the paper that came from Jonathan Bamber et al., and the 5 to 95% range gets into the 2-meter range. So those are the kind of things where decision makers don't want to jump and just guess, but they want to see a broader view of what the science says and IPCC says. That if IPCC, the methods IPCC used in the past, finally IPCC is moving toward a true risk assessment approach where you can see the full range of belief in the scientific community.
Thank you very much for that, and I think it's a very good transition into our next panel. I'm delighted to welcome to the panel Her Excellency Mrs. Janine Coy-Felsen, who is the lead negotiator for AOSIS. AOSIS is the Alliance of Small Island States, though I think you should change your name to ALOS, the Alliance for Large Ocean States. Small campaign there. But it's it's a coalition of 44 small island and low-lying coastal states. And so we'd be delighted, Janine, if you'd perhaps give us some perspectives from IOSIS on the IPCC and what does it mean. I understand you have some slides. Great, here. And if you just want to sit from there.
Yes.
And we have the advance there.
This is an ad hoc slideshow.
Perfect.
Because I realize that it's important to have a context of what exactly we're talking about when we think about the IPCC special report from a SIDS perspective. Thank you for introducing me and for highlighting the fact that I'm representing 44 of the most vulnerable countries in the world, who are, as you saw from Adele's presentation, experiencing the extreme events that come with climate change. Sadly, we have the reminder from Dorian that there are other extreme events that we experience that don't come up on your news screen regularly. And that is, of course, the sea level rise that we have, droughts that are occurring in Belize. We have a partial state of emergency because of a drought that basically nixed our wet season. We have 2 seasons, dry and wet. We have no wet season, no rainy season right now. The warming temperatures of the sea, that's significant because it threatens our precious natural assets, like our coral reefs, and it reduces the potential for fish production, all again reinforcing the vulnerability of our communities. We're also very highly dependent on, I'm not sure which thing to press.
Yeah, there you go. Yep.
Highly dependent on oceans and its resources to sustain our development and the livelihood of our people. We have some of the most diverse marine ecosystems in the world, which have contributed to shaping our cultural identity and the way of life of our local communities. On average, the EEZs, exclusive economic zones for small island developing states, is sometimes 28 times a country's landmass, making our marine resources a major economic asset and major source, again, of our livelihood. And because we have very limited options for economic diversification, in many cases, those resources are the principal drivers of our economies. Stemming from this is the ecological and oceanographic connectivity between areas within our jurisdiction and areas beyond our jurisdiction, which really emphasize the importance of the health of marine biological diversity, both within and beyond. Especially for the survivability of SIDS, but I think it's important to also mention that this is of global significance. And to put this in perspective, I wanted to give you a snapshot of what we, as small island developing states, what we share as our biodiversity, what we have as our responsibility for the world. So in the Caribbean, we have something like 10% of the world's coral reefs and approximately 1,500 species of fish and marine mammals. The reef surrounding the Caribbean provides nursing grounds for many northern Atlantic migratory species, including the humpback whale. The shallow marine environment of the Caribbean hosts 8% to 35% of endemic marine taxa. Belize alone hosts the largest barrier reef in the northern hemisphere, with offshore atolls, several hundred sand keys, mangrove forests, coastal lagoons, and estuaries. The system's 7 sites illustrate the evolutionary history of reef development and are a significant habitat for threatened species, including marine turtles, manatees, and the American marine crocodile. In the Pacific region, our islands there host 476 globally threatened species, over half of the world's known species of cetaceans, the majority of remaining dugong populations, and the largest groupings of hawksbill, green, and loggerhead turtles are all found in the marine regions of the Pacific SIDS. The World Wildlife Fund's Global 200 list, which prioritizes ecosystems for conservation, includes 5 outstanding coral ecoregions in the central Indo-Pacific SIDS, the Bismarck Solomon Seas, the New Caledonia Barrier Reef, Palau, Maine, Tahitian Marine, and the Fiji Barrier Reef. The Phoenix Islands Protected Area, PIPA, is one of the largest UNESCO World Heritage Sites and is the largest marine protected area in the Pacific, and it is recognized as a place of global significance. The islands in the ACE region are extremely ecologically diverse and feature numerous ecosystems and biomes. The Indian Ocean is home to 10,000 shallow water marine species, including 2,000 fish and 4 species of marine marine turtles. So I can go on to extol all the richness of the biodiversity, but we're here to discuss the SROC. And for SIDS and for the world, I think this report opens up a whole new chapter of the climate legacy that we will leave behind. Because all of these beautiful things that we house in our home, but which is also your home, are completely at risk with climate change. Anything going beyond 1.5 degrees. I don't think I need to go through what this report means for SIDS, because you've had the presentation from Adele and from Mikhail that clearly outlines the risks that we face. But I will leave one, or underscore one message, which is the risks are now for us, the small island developing states and least developed countries, but the risks are clearly your own. So thank you very much.
Thank you very much for that, Janine, and certainly laying out what we clearly stand to lose, and the importance of these systems and assets and biodiversity, to the way of livelihoods and indeed a way of culture, and that culture, how it has been ingrained and intertwined with the environment over thousands of years, I think is incredibly important. I think it's also now time to sort of switch gears to look at the least developed country perspective, and we're delighted to have with us Mr. Sonam Phuntsho Wangdi, who is the Secretary of the National Environment Commission of the Kingdom of Bhutan. He's also the chair of the LDC group on climate change. Mr. Wangdi, please, could you offer some thoughts from that perspective? Thank you.
Thank you. Let me thank the presenters for very succinctly presenting the report, the last report. I believe that in the last few years, this is the third of the series. These reports, the scientific basis, the evidence, I think has brought to the fore and almost a wake-up call in terms of the urgency of climate change in this world. And the LDCs are the most vulnerable. They are at the front line. Today I am probably not going to be able to talk about all the LDCs. We have all categories, but I'll concentrate more on the mountain part, and that's a Bhutan, from my country experience. The AOSIS covered, we also have the island countries under LDCs. The mountain ecosystems have been accepted as fragile even long before these reports. And we have known that in all mountain countries, the mountains, we've been losing the snow cover. It was just in terms of the magnitude, the duration, how much. And this has, in fact, very deep implications on the livelihoods of the people in these countries. For Bhutan, we are in some way a little different. We've been a little careful, but we are not, again, immune or rather protected against this, the consequences of what others do. We are least responsible, but most affected. I mean, the LDCs in general. So, for Bhutan also, we have, I'm not a scientist, I'm not an expert from that perspective, but nevertheless, as a citizen, we have experienced, growing up, we have experienced that we are losing our glaciers. The weather, the extreme weather events have come in. We've had landslides, and that affects, in Bhutan also, in all LDCs, 60 to 70% of our people are farmers. And for farmers, water is essential. And even precipitation, both in terms of the glacial runoff and the precipitation through the rainfall, is very important. And in terms of the climate change, in that it's going to have severe consequences to the livelihoods of the people, agriculture. then if you go a little further to industry also, many of these countries, especially the Himalayan, they're dependent on, let's say, hydropower. And that's actually a good thing. It's clean energy. But they're very expensive projects, very expensive. It costs almost $1 million a megawatt. So, a project would cost billions of dollars. So for us, that is, again, a major concern in terms of, again, in terms of having that water to run this. And these projects have a duration of 30, 35 years to pay off the loans. So for particularly Bhutan, I think we have high potential, likewise Nepal. Most of us, and many high countries I know have this potential because hydro is about, the drop. These high countries, for Bhutan, is 7,500 meters, and we come down to 50 meters in about 350 kilometers. So that gives rise to this. So this is another very, very serious concern in terms of, and I have often, even the UN has done some studies, Norway has done some studies, and we've tried to see the 50-year perspective also. Where do we stand? Is the water going to dry up? So far, the answer is not very clear, but it's going to really impact us very negatively. The other important, again, is tourism in this mountain. Tourism is very important, and as long as you have your glaciers and your snow cover, whether it is for hiking, skiing, you have this. And once you lose it, again, you have a problem. The other important part is the disaster risk. Now, we've, in fact, these disasters have been quite frequent. Just this year itself in Nepal and even Bhutan, inundated. We have these, with glacier melting, the number and size of these glacial lakes. In Bhutan itself, we're a small country, we have 760 glacial lakes up at 4,500 meter plus. So these lakes, when they burst, it's called glacial lake flood outburst, GLOF, we call it GLOF. And it's a flash flood. It sweeps anything in its path. Valuable, besides lives, valuable infrastructure. So that is another. So we've been, in fact, all of us have been affected by this. We've had flash floods, we've had windstorms, and we've had in higher altitudes avalanches. So these continue. These are. It's actually what you call. These are reality. It is no more in terms of the risk where we say that climate change. In fact, I wanted to ask a question in terms of how in specificity, and my colleague talked about what's the worst scenario for the least developed countries or the island countries. The mountain, especially the Himalayas, in terms of the glacier melt, how we are not very sure. The report it's a very macro, wide coverage, and if you actually zoom in and you look at this, you'll find that probably, from my own experience, I'm not a scientist, but it is grave. They say that the temperature rise higher with altitude. It's magnified. It's 4 times as much. So if we're talking about 1.5 degrees, you have to multiply that 3 times or 4 times. So this is still not known. So we actually don't know. So basically, the report itself is dire. It talks about if it goes above 2 degrees, we are going to lose about 18% of the glacial mass. If it's at 4 degrees, 36%. The runoff, talking about if it exceeds 4 degrees, your water runoff is going to reduce by 10%. And in our area, the IC Mode has done some studies, and they are saying that even if you're able to limit to 1.5 degrees, by 2100 in the Himalayas, we're going to lose a third of our glaciers. that's given. I mean, they have just declared. It's not. So we are going to suffer, and what it means is that I believe we have to do more. Especially the ones who are responsible have to do more. And the Himalayas, especially, are the mountain. We talked about biodiversity. It's one of the most pristine areas in the world. We have, in fact, the belt. Some of the species that are being lost, endangered. We have many species, including the tiger, the Bengal tiger, the hornbill, the golden langur, the red fox. There's so many, and if we need to protect these, I think we need to act, and we need to act now.
Thank you very much.
Thank you.
Thank you very much to you both for really grounding, the issue of what we're talking about here on the front lines, as it were, and clearly, climate change from the poles to the tropical regions, from the highest mountains to the deepest parts of the ocean, is impacting these systems. I'd like to open now for questioning, but I'd like to direct the first question to you, Michael, and if you could perhaps respond to Mr. Wangi's concern that is there sufficient science there telling us of what's happening in those higher elevations? Is it there? And perhaps what are the implications of that?
Well, there's sufficient science to know some things and not others. The models are pretty good at temperature. They have a very checkered history of precipitation. It's a balance between warming and excess accumulation of snow that matters for glaciers. So, the so-called mass balance calculations are projections. Projections are, shaky for individual glaciers. I think the overall picture you painted is right. There are losses now at the lower Himalayan glaciers, and the upper ones, some of them may still be growing, but that isn't going to last. And some of these communities are going to have to plan for a future without that water being available, for instance. But when you get down to the detail, it's one of the rougher ends of the problem. Let's put it that way.
Interesting. I'd like to open now to the audience for questions. And I see we have a hand right there first. Thank you so much. Could you say who you are, please, and where you're from?
Yeah, hi, good morning. My name's Cooney. Most recently, I was with the Nature Conservancy. I focus on ESG and impact investing. So my question is on climate change as a social inequality issue. And we know the simple answer to this is yes, but I'm just looking for more data around this issue on how we can talk about how the poorer countries in the world will be disproportionately impacted by climate change. So can you share with me any data that you have around that?
Janine, would you like to come in on say a few words about that, please?
Thank you very much. We have this issue with data in small island states as well as in least developed countries. Our data capacity is very constrained, and we recognize that that's something that we need to address. If you look at the 2018 report on the Sustainable Development Goals, where you see a lot of information that would give you the sense that we're not going to meet many of the targets that we've set under the 2030 agenda, but it doesn't really tell you that there is insufficient data, especially on indigent and vulnerable populations. So in fact, the situation might be even more acute. What we have and what we've typically relied upon is basically data that comes out after a major impact. So when the hurricanes from 2017, my goodness, it seems very much more recent, having had Dorian. The impacts were, in the case of Dominica, in excess of 200% of their GDP. And we've seen that in Grenada with another hurricane much earlier on in the millennium. But these are not going to go away. And if you speak to any one of my countrymen or women, and you ask them the question, well, what's the cause? How do you explain a disproportionate burden? If you're contributing very little to nothing to global warming, then even $1 spent to deal with the situation is a disproportionate burden. So we need to deal with the challenges of data to better understand. We've heard from Professor Oppenheimer of the importance of looking at risks, and we need to focus on how we develop that capacity. But until then, I mean, it's clear empirically that small island developing states, the people of small island developing states are certainly suffering the most critically from our lack of action at the global level. Thank you.
Mr. Bundy, do you want to come in from the LDC perspective? And then perhaps, Michael, if I might just draw upon you to sort of respond to see where the opportunities in data and what's perhaps how do we sort of challenge this group and audience in taking that forward. So Mr. Bundy, please.
Yes, thank you. Yes, I agree with USS that we have problems in terms of data. But for the LDCs, we recently did our Life Year Adaptation Resilience program. Our universities did some research, and the research actually gave an insight into the vulnerability. Now, in terms of how we suffer, how much we suffer, the LDCs, we are about 1 billion people. That's about 13% of the population of the world. And in the last 50 years, only 18% of the disasters occurred in the LDCs, 18%. But we suffered disproportionately in terms of the deaths. We had 69% of the deaths were in the LDCs, while we had only 18% of the disasters. So this actually gives you a sense of this vulnerability. Also, in the last 5 years, we lost about 8,500 people, and this affected about 105 million people. So 1 in 10 people in the LDCs were affected. So this is, I mean, just to give you a sense of the vulnerability. Thank you.
Michael.
Well, it's an issue that the SROC report tries to deal with, although quantification is difficult. And the general assessment was that this is a question, that the issues related to coasts and oceans and high mountain areas, that is filled with distributional inequities, a lot of unfairness. And it's not just, although most importantly, it is the poor countries, because they're not just their vulnerability, but a lot of them, people are exposed in a way they aren't in many developed countries. But also, in developed countries, there is disproportionate exposure, higher vulnerability, and fewer resources, and much less political influence among poorer people. The best example is, what happened in Puerto Rico after Hurricane Maria.
Yeah.
For many reasons, lack of political clout, racism, and importantly, that the U.S. funds and manpower for dealing with disasters had been exhausted by Hurricane Harvey, which had occurred a few weeks before. Puerto Rico was left there hanging, and that's a distributional issue because it involved resources locally, resources federally, and political power, and none of it was there. So you look for that story, and it's all over the place with this issue. Who lives in floodable areas, after all? It's people who couldn't afford to live in other areas. And so, there is no solution to this problem in terms of really not just cutting emissions, but protecting people, because we're never going to be able to cut emissions enough to avoid impacts. We've already got them. That doesn't involve grappling with this problem. Now, the world doesn't have a great record in grappling with the problem, but in some ways you can argue that things have gotten better in some ways. But this is like, the way I look at this, sure, the world is slowly inching in a direction where people who were very poor, there are more people who are literate, etc. But this is going to be a setback, and the higher emissions are, the bigger the setback is going to be.
Critically important, those social dimensions. Do we have another question? Take this one in the front here. You've had your hand up for quite a while.
Thank you. Victor Yosha from ECOS, an education constituency newly forming in the UNFCCC. My question relates to food safety and SIDS health and communicating this report, and perhaps a broader open question. So today, due to saltwater intrusion, pests coming in with mooring, some of the cities face crop failures, facing to move to new diets. And it's just that they're not used to. And being reliant on processed imported foods, changing to Western diets, which causes diseases. We know these diseases. These are non-communicable diseases of civilization. You call them cancers, diabetes, cardiovascular diseases. And their health systems administer these diseases now at a faster rate. And my question is, today, how can we use this report to underpin advocacy like this and points like this that take place today? Because this report looks at a mid-century, end-of-century scale, but some of these things are already, these impacts are taking place today. How can we make best use and communicate this report the best way for this?
Thank you very much. Janine, can I come to you directly on that? Simply because I think the reference to the sort of shifting diets as far as small and developing states are concerned. And I mean, are you starting to see, through the IOSIS, is this starting to be of concern and discussion in this context?
I wanted to take it from a different angle, but,
sure.
I will come to what you've asked. I think what your question opens up, it's not so much how the report itself can underpin action on addressing food security or public health related issues. I think what it opens up is a front for us to look across different agendas. There are many agendas already. FAO has a specific compact or program for small island developing states. We have a non-communicable diseases political declaration. We have the climate change agenda. We have the sustainable development agenda. Yeah. It's how do we use the messages from this report to try to see how these different agendas can work together in order that we can see greater deliverables, whether it's through the food security lens or through the public health lens or through the climate change lens. I think that's a very big challenge because we have all these various policy processes that work very differently, work in different timelines. But I think that is one of the bigger challenges, cutting across these agendas with the messages to ensure that we're working in a complementary fashion to address some of our bigger challenges. I hope that's helpful.
No, that's very helpful. But can we just come back to the point? I mean, is this, is the specific point that he's raising? I think it's quite, because it's a very important one in terms of understanding some of the challenges there. And I'm just curious if that's coming up in discussion.
Yes, I think it's that's a very important point. How it's impacting what we eat, when we eat, the fish productivity, the fisheries productivity. That is definitely something that we're currently experiencing. We're also seeing challenges in the level of production of our fisheries. We also, in terms of agriculture, just to speak to the whole issue of droughts per se. In Belize, our agriculture is one of the main drivers of our economy, and already we've experienced in the past couple months $50 million worth of losses from a drought, and that's just in agriculture. We haven't even expanded that to see what that means in terms of GDP. So yes, it is something significant that we are going to have to contend with, and it's easy for me to respond to the impacts. I think it's also important for us to contextualize that, because we also need to understand what has been the agricultural or growing patterns for the Caribbean as a whole, where we've oriented ourselves to deal largely with an export market, and now we actually have to deal more directly with how we feed ourselves.
Yeah. So, Michael, can I just pick up on that? I'm going to come back to the audience in a second. So, on that point, in terms of food, did the IPCC report, really start looking at this sort of, to Janine's point about working together on agendas? Because obviously this is, the things that are messages are coming out of it. Does the IPCC report start to heading in this notion of food and the impact that that these projections are going to have on food production? I mean, you alluded to it earlier, but I just want to unpack that a little bit.
I've been so busy with the SROC report, I haven't looked at the land use report, which came out a few weeks before. So I don't want to make it up, so I'm not going to give you your answer. I will say, in the context of the SROC report, there's quite a lot about the sustainability of fish yields and all the multiple.
Yeah, I was actually specific on blue food, so just from the ocean, yeah.
No, solid. I mean, I know this and that, but I don't want to dive into my apparent expertise by crawling over the edge.
Okay, good. Well, yeah, I think it's obviously something, we had our speakers earlier talked about, changes in biodiversity and shifting patterns, and that biodiversity obviously is important for food and livelihoods, and I think that's something, we need to think about in terms of adaptation and how we manage that and the policy implications for that. Another question, we have one at the back there.
Thank you very much to the speaker and Climate Analytics for organizing. My name is Luca from E3G. I wanted to ask you how you judge the outcome of the UNSG summit, and how would you define success, or what you expect next year at COP26? Thank you.
Mr. Wangi, I'll come to you first, and then perhaps Janine, you might want to come in.
Thank you for the question. I believe that a very impressive effort has been made to provide political motivation to enhance ambition and action. This is what the implementation of the Paris Agreement is at our door. In 2020, we are supposed to be implementing it, and as we stand, the efforts are not enough. We know the NDCs, everything, and so this was the reason why the LDCs had also requested for the summit. I'd like to be positive, but there was no magic. In terms of the pledges, I believe that a lot of interest, people have come around. I believe there is a lot more awareness, and many countries have made pledges to the GCF, to the LDCF, and also to some of our initiatives. Pledges have been made, but from the very large emitters, still it's not enough. But we believe that this is the starting point, and the action is going to happen in COP25 and beyond. I believe that it's going to get much more impressive as we go forward. So I'm very positive about it. The outcome, the report is going to come out soon, but this, let's say the gut feeling that we have is things are going to change, and it's going to be much better in the near future.
Thank you. Janine.
I think there are certainly bright spots from the summit that we cannot lose sight of. We do have 77 countries that have committed to net zero by 2050, and we need to take the effort forward to drive the momentum so that more and the more critical ones are stepping up to that commitment. I think it is also important that the summit did lay very clearly out the challenges that we have in front of us from a political standpoint, from a business standpoint, from a people standpoint, and I think we need to frontally address those challenges. It is not going to be only up to governments to do that. It's not going to be only up to the Secretary General's team to do that, to follow up on initiatives. It's all of us. And I think that's very important, and that was very clear. I'd like to think that the summit was just the tip of the spear, and there's a lot more that will have to be done. We need to look to COP25, as you rightly pointed out, to start really pressing forward on what we need to accomplish between now and I would say October of next year. Thank you.
Thank you. We have time for one more question. Yes, back there. If you could be quite brief, because we're
yes,
running out
I
of time.
work with a Catholic advocacy group here in the metro area of New York City. And my question is about carbon offsets. You know, it's like, it seems like the developed countries and those of us who want to kind of get rid of our guilt about our fossil fuel carbon footprint, we buy offsets. And I just wondered if you could comment on the whole issue of carbon offsets and their effectiveness in, I mean, it's like we're not reducing our use of electricity and fossil fuels by buying a carbon offset. We're kind of getting rid of our guilt, it seems like.
Exactly, yeah. Michael.
So if countries were making all reasonable efforts and still not meeting the objectives they had set, which in some cases are ambitious in some sense, then offsets might be a way to get something done that would not have or otherwise been done. And there are ways of doing offsets that help build local capacity and move sectors and countries in the right direction. Unfortunately, I think you'd have a hard case proving all in all that that's the way the offset systems in the real world have operated. So I personally am skeptical that any conversation should start, I'm not criticizing you raising the issue, of course, should start with offsets. Governments, shouldn't be focusing on them as the thing that they're going to do. I think largely it's been a safety valve to let off political pressure in certain countries, particularly my own country, around the Kyoto times. And, it just hasn't worked out as leading all that far. On the other hand, you can find cases in developing countries where the investments related to offsets have probably done some good. I have one more question, thing I want to say that's a little off this that relates to some of the other things we're just discussing. I think that you have to realize that, although I think this problem will be solved in some way eventually, you can't count on the big countries, given the political disorder in the world, to really take big steps now. We saw that at the UN. So I think it's very important to talk honestly about the need for adaptation, because it's going to help fill the gap while we wait around for these big actors to actually do what they should have done in the first place several decades ago. And there are good stories, there are success stories with countries and areas within countries that don't have the resources to get together and do things that protect people. The best story is Bangladesh. 500,000 to 1 million people died in cyclones in 1970, a big cyclone. Recently, they've got the death rates down by more than 2 orders of magnitude. They did the relatively cheap stuff, bunkers plus early warning system. This is the kind of thing that doesn't even get done around here. There's a lot of knowledge, and there's money for this stuff, I would hope, from the bigger countries. And let's get some focus, at least, on protecting people, because they're damn well going to need to be protected.
I think that's a very important point to end on. Clearly the IPCC report tells us that we need to raise our level of action, raise our level of ambition, and look at actions now that are going to buy time as far as adaptation is concerned, as the point you made. And let's not forget about the people. We can get caught up in the science quite quickly, but there is clearly a people dimension that is from the mountaintops down to the sea. And I also think that it really is a case of, we can go alone and we go slow, or we can go together and go fast. And I think it really behooves us to really think about our models of partnerships and the role of business and government and how we, tackling this issue. There's just no way that we're going to find any silver bullet to this issue. And I think this is exemplified by some of the points that have been raised by our panelists. So I hope that this session is giving you some insights, food for thought to take away back to your home institutions and countries, and encourage you to take further action on that. So with that, I would like to, before I introduce Bill Hare, who's the Chief Executive of Climate Analytics, to give him the final word, as it were. I'd like to express our appreciation for all of our speakers this morning, so thank you very much. Bill, can I ask you to come to the podium, please, and just say a few words? Thank you.
Great. Look, thanks everyone for coming to our second event here. Just wanted to offer a few observations to wrap up. I think the message is to go together and go fast. Otherwise, there's no way of dealing with the kind of problems that we've seen coming out of the most recent IPCC report. The other key message is that even if we limit warming to 1.5 degrees, adaptation is absolutely fundamental. And it's very clear that for the small island states and least developed countries and many others, there simply isn't enough resources there. So in the code of the negotiations, means of implementation, finance is absolutely critical. The other question is the one that was asked, I think, by the IKEA Foundation, which is about how on earth do we mobilize countries to act on the basis of what we are seeing coming out of the science? How do we encourage countries, build them up to move forward on adaptation, on mitigation ambition? I think the summit we had on Monday was very disappointing in terms of the content. And in many senses, it's at the very least a psychological setback. The Secretary General was very courageous to actually do that. And I think we all need to find ways of continuing to give the Secretary General and global leaders the courage to keep moving forward and come back at that ambition issue. It's very clear to me now that COP25 needs to be in Santiago an ambition COP. And we need to be using our networks, all of your networks, to work with countries at the national level to encourage leaders and governments to step up on mitigation ambition and to mobilise their politics, their civil society, their industries, their companies to actually do more and provide more space in emission reductions to essentially prevent the kind of catastrophic changes that are coming through the IPCC report. So thanks once again for coming. Thanks once again to the panelists and the speakers. And thanks once again to my co-climate dinosaur, Michael Oppenheimer, for appearing here again. Thank you very much.